Hey, let's travel back in time to Unit 3. And why don't you tell me where this function f of x has a max or a min? We're back in time, we're in Unit 3. Please tell me when that function f of x has a max or min. Unit 3 is a review. Why did I start in the middle? Weird.
Yeah.
All right, I don't know.
Right.
Yeah, that's not bad. All right, start remembering how to find maxes and mins. Oh, you guys are so locked in. That's great. That's great. Nope. Forgot a key step. No, you're good. Yes, too far actually. Way too far. Forgot a key step. Forgot a key step. You forgot a key step. Everybody is forgetting the key step of taking the derivative and setting it equal to 0. Take the derivative, get the slope equation, because the slope equaling 0 is when the derivative changes sign. When the derivative changes sign, your original function changes direction. Signs of a derivative tell you about an original function increasing or decreasing. It's so funny how we forget that so quickly. Guys, this is just like a position function. How would you find a max or a min of a position function? Of the derivative. Make sure you say of the derivative. The exact same way, guys. The exact same way. If I ask you for a max or a min of a position function, you would do the exact same thing. The only thing that changes is that this is a t and this is a t, and these are t's, and this is x prime, which is a velocity. It's got its own fancy word, and this is x. Okay, so like first things first, f prime, x prime, the same. And we are going to be doing maxes and mins today. But there's more. There's more. What if I gave you the graph of the derivative? Well, you would see when your derivative equals 0. So you're not looking at this point. You're not looking at that point. Many of us will always go to those points thinking that's the key. But no, we look for when the derivative equals 0. That's at 1 and at 3. Or I guess that's 2. And this is the derivative being negative and positive and negative, which is telling me what my original function is doing. I could change this to be x prime or v. I could change this to be x prime. This is x. Okay? But what did we learn this unit? What was really the new thing this unit, besides the fact that we're using x, v, and a instead of f prime, f double prime? The fact that we're talking about positions, no, it's really just like an f. The fact that we're talking about motion, it's just like an f and an f prime and f double prime. What has been the new thing that we have added to this sign analysis? That's really the one new thing that you guys are learning. Tell your neighbors. The idea of accumulating a derivative, whether that derivative is f prime or x prime, tells you how much you're going up and how much you're going down. New information. The accumulation of a derivative, whether it's f prime or x prime, it doesn't matter. This is a new thing. It tells you how much you're going down and going up. Because you know this new line, I have greater expectations of you for these max-min questions. Sure, you'd say this is a max. Sure, you'd say this is a min. Sure, you'd say that's a min, that's a max. But now I'm going to ask you, are they the absolute max or the absolute min? And we will start using the word absolute extrema, which is an overall maximum. What I'm going to do is stop my sign analysis so that it has a start and an end. We are going to have what's called a closed interval. And what we've done already in Unit 3 will be used, but with the additional sign analysis, the additional derivative accumulation analysis, we're going to be able to figure out which one of these will produce an overall max and overall min. The only thing that's going to be different is we're going to have to, use our displacements. Which now I'm just going to call a full sign analysis. There's no more layers, thank goodness. Like, that's it. After doing a full analysis, your maxes and mins overall will either be when your derivative equals 0, these points that we found before that we'll find again and again, but we also could have a max or a min at an endpoint. So I'm going to say the overall maxes mins using displacements in my full analysis, they could be when my derivative equals 0 or an endpoint. For example, I got a closed interval. I got a start. I got an end. I'm going to denote by S and E. And I'm going to have some 0 of my derivative at A. Again, this is F prime. It could be X prime. It's the same idea. This is telling me F is going up, then going down. Do we know a location of a overall max or min? Tell your neighbors. What letter could be an overall max or min, or has to be an overall max or min? Start with that. A's got to be a max. Great. Where's the min? S or E, we don't know. Well, this is where we break out the accumulation of our derivative to figure out how far did we in fact go up? How far did we in fact go down? What if I, using my calculator or from my antiderivative, from my position function, from my S function, my F function, I find that the accumulation F prime from S to A was +5, and then from A to E is -3. Okay, tell your neighbors, where is the min? Is it at S at the start or is it at E at the end? Go. So this is funny. A lot of people actually said the wrong answer. What is it? C. C. I don't know where S starts from. Okay. Ready? I don't know the Y value at F. We could call it C. Whatever my initial value is, there's where it is. I'm going to go up 5. and then I'm going to go down just 3. Overall, I increase 2. I end further up from where I started. Guys, yeah, sure, that's my max overall, but that's my min, where I start. I go up more than I go down. My min had to be where I start, and that's okay. How would I have known that? Well, not unless I had this. Now that I have this, we should be able to see where it is. Okay, so let's see if we can figure this out. F is going to be decreasing, then increasing. It's going to make up some numbers. F prime is -2 and then +4. Where is the max? Where is the min? We'll call it SAE again. Start, some 0, end. Where's the max and where's the min? Where does it start? I don't know. It starts at C. It starts at C. This is where it starts. Then it decreases 2. So this is C -2 or -2 plus C, whatever you want to do. -2 plus C. And then it increases 4, which ends up being +2 plus C. Because overall, my overall displacement was 2. The overall change in my function is 2. So through that analysis, the fact that I went down 4, then down 2, then up 4, yes, we knew that that had to be the min, but now we know that this endpoint has the max, and the only way I can figure this out is by analyzing my displacement, whether it be from the function values or from however I find my displacement. Okay, let's do another one. I got a start, I got an A, I got a B, I got an end. Here are the accumulations of my derivative over these intervals. We got a +5, a -4, a +3. Where are the maxes? Where are the mins? Hey neighbors, what do you got? SABE. No, I want the overall max and the overall min. The questions I'm asking is overall. Okay, so I start somewhere. I am 5 more than where I started. I'm then 1 more than where I started. And then I'm 4 more than where I started. I have a max at A. I have a min at F. How do you figure this out? There's so many different ways to kind of like understand what these values are telling us. Now, I'm going to throw this at you. What if I had an antiderivative out there? And what if I knew F at my start was 3, f at A was 1, f of B was 7, and then f at my end was 6. What if I gave you all those values of f? Let me just kind of zoom those in. What if you knew the value? That didn't really help. But what if you knew f of A is 1, f of B was 7, and f of E was 6? Where's the maximum, where's the min? So like, what's really interesting about this is like, you could find the displacements here. You could find the areas of your derivative. You must decrease 2, increase 6, decrease 1, right? But guess what? You know the value. You have your candidate. You can just look which one of these 4 will produce the smallest value, which one will produce the largest value. Oh, 1 is the smallest, that's the min. 7's the largest, that's the max. So whenever you can like just look at values, it's helpful to just look at values. Whenever you have to look at displacement, okay, do a little bit of analysis, look at displacement. Let me show you what that's going to look like with these questions. Now, the way we're going to be asked about absolute maxes and mins with motion is the following. When is your object furthest left? They're going to ask this question in this way, furthest left. You will immediately translate that question furthest left to, oh, I want to find a min of my position, a min of my original equation of my f. How are you going to find the min of something? You take the derivative, you set it equal to 0, you do your full sign analysis with maybe some displacement analysis too, if necessary. Take your derivative, set it equal to 0, do your full with your accumulation, with your integral kind of layer sign analysis. You will compare your candidates, which are when your derivative equals 0, and your endpoints, because your endpoint can produce a max or min. Obviously, furthest right would be a max of position. The same process still would be done. You would take your derivative, set it equal to 0, look at your endpoint. I could ask you for like when you're going fastest right or fastest left. Typically, they'll ask literally just for like a max velocity. A max velocity could be translated as like fastest to the right, but I usually don't see it like that. But I think I have some homework questions asking you for when you're going fastest right. Now tell your neighbor, if I ask you for a max velocity, what would you do to find a max velocity? Yeah, this is when you would look at the derivative set equal to 0. Oh, that's your full sign analysis, but not of your derivative, but of your second derivative. Versus your full sign analysis, which is your velocity analysis. Okay? So make sure you understand, are we looking at our first derivative sign analysis or a second derivative? Primarily, we're going to stick with our first derivative analysis. So here is our first question when I'm asking you for furthest right. It's still just like finding a max of f. You think of position as being your f function. They're giving you an f. You're going to take the derivative. You're going to set it equal to 0. Do it. It's always going to be your first step. It's like, really for this entire unit, all about understanding your full sign analysis of your derivative with your extra layer, which is really the only new thing we've learned. That if you accumulate a derivative, whether it's using your calculator or by using an antiderivative, you can understand how much you increase or decrease. One thing that's going to be different is I'm giving you a start and an end. So I want to start at 0, end at 3. I have a time of 1. Think of these like x values, but they're times that will give us positions that are x. I know that's been confusing, but I feel like the more and more we just get into this unit, the more we kind of understand what things mean. We now have our derivative. It's 0 and it's signed. I plug in 0 or even like a half, I got negatives. Something to the right of 1, I got positive. Now, this tells me what my function's doing. I know where I'm furthest left or furthest right off the bat. Which one do I know right off the bat? Tell your neighbors, which one do you know already? Furthest right or furthest left? I know my position decreases then increases. This must be the location of a min. It must be the overall min. I didn't have to do any accumulation analysis. Now I'm asked for the max. Well, guys, watch. We would love to do an accumulation analysis, but it's not necessary because we already have the equation of the position. We already know the 3 times that are candidates. This is very important. T equals 0, 1, and 3 are what we call our candidates. We know our maxes and mins either occur when our derivative is 0 or an endpoint. This is the extreme value theorem. I don't know if I wrote that down. Absolute extrema, overall maxes and mins. They could be at a derivative that equals 0 or an endpoint. This is what we call an extreme value theorem, the extreme value theorem. Pretty much like the extreme value theorem is what we know. You need to look at a derivative equal to 0, a sign analysis. But since we're kind of capping our intervals, we could have maxes and mins at our ends. So knowing that our start could be a min, a start could be a max, et cetera, et cetera. Okay, so back to where we were. All we need to do is find the positions of our 3 candidates. What's x of 0, x of 1, x of 3? Now, this is very important. Make sure you understand what you're finding. This was signs of my derivative. These are my actual positions. You plug it into the position function. Plugging in 0, you get a position of 0. I'm going to decrease. Plugging in 1. Okay, this makes sense. I have a position of -1. I went from 0 to -1. I've reached a min. Plugging in 3, I get 9 minus 6. That's 3. I've increased from -1 to 3. Now you, with this analysis, know your displacement. You now know the distance traveled with that extra layer. I didn't ask you about those, but now that you have it, say on a free response question, you'd be able to answer any question that I asked. What was the distance traveled over 0 to 3? When am I traveling to the left? When am I going towards the origin, away from the origin? All those different questions you could ask, but my answer here, that's my max. That's the largest of the 3 candidates. If I decrease 1, then increase 4, I started 3 above I ended 3 above where I started, just like I can see with my value. Okay. Let's try the same one. I want you guys to try it yourself because I really talked to you through that. So when is the object changed from moving fastest to the right to just, when is the object furthest left? And you immediately translate to a min of position. No. No. Oh, you're still not out? Cool. Now, again, we don't take our position and set it equal to 0, even though that would provide some good information. We take our derivative. Our derivative, its values telling how quickly the function is changing, the original function. Getting a value of 2 and 0, that's when my derivative equals 0. Doing your sign analysis, knowing that we were stopping at 3. I would love a displacement analysis, but I don't have a calculator. But you know what? It's easy to find because I have what we've been calling the antiderivative. I have the original function. I have everything I need. I can find my position at time 0. It's 0. I can find the position at 2. 8 minus 12 is negative 4. I have the position at time 3, which is back to being 0. Now I know everything about how this object is moving. It's decreasing. It's going to the left by 4. It's then going to the right 4. It's traveled a total of 8 units over these 3 seconds. It has 2 maxes. It ends up back where it started, but it has 1 min. X of 2 equals negative 4 is the absolute min. It's when it's furthest left. Got this? Now, what if I went ahead and asked you when it's moving fastest to the right? Or what if I asked you for the max velocity? If I ask you for the max velocity, what would you have to do? So we found the absolute min position. This is when I'm furthest left. If I ask you for the max velocity, understanding your velocity is your first derivative, you got to take the derivative of that derivative. You need a second derivative sign analysis. Your second derivative sign analysis, focus on 1. Now, here's where it gets a little tricky. Even I got tripped up a little bit earlier. Pay attention and have everything labeled. Here's my second derivative. Here's my acceleration. It's negative. It's positive. It's negative, then it's positive. See, I'm already getting confused. Okay. It's got a 0 and 1. It's telling me that my first derivative or my velocity is decreasing than increasing, right? The second derivative tells us about the first derivative. How much did it decrease or increase? Oh, well, since I have a velocity function now, you've got to make sure you find the correct function. This is my velocity. You would find your velocity at 0, your velocity at 1, your velocity at 3. I don't even need to find my velocity at 1 because I know it's a minimum velocity. But make sure you plug it into the correct equation. My velocity at 0 is 0. My velocity at 1 is -3. Okay, that makes sense. I decreased 3 with my velocity. And then my velocity at 3 is 27 minus 18, which is 9. So I had to increase a total of 12. There is my max at the end. And we haven't done this much, but our second derivative sign analysis, you know, you'd find your first derivative values, your velocity values, to fill everything out. Okay, now, those have been easy because we've had equations to plug into values. But what if I give you this? Now, it has been a complete failure the first 2 class periods, so I'm going to just go ahead and reveal the mystery information. Hopefully this will help you. Team, this is the velocity, which is the derivative of position, and the mystery information that hopefully will help you guys, because not having it really hurt the first 2 class periods. That the position at time 0 is 5. Everybody fill that into your notes. Here is the velocity. Here is the accumulations of the velocity. Here's the accumulations of the derivative given to you. You already have the derivative of position. You already have f prime. Please analyze this derivative fully and tell me when and where are you furthest left and when and where are you furthest right. And I'm going to come around and see if you guys get it, because we should just get these answers like that. Go.
I did it in my head.
Oh, well, you're wrong with one of the 2. Thanks.
Can you tell me which one?
No.
Oh, it's your 4. Wait, I'm changing 4.
Do the analysis, write it down, and we will understand. Just look at the value, Joe. You got the values. No, look at that, and that. You got them. Not 4. Thanks, Shadi. Okay, having this piece of information is very helpful to a lot of us. Thank you. Write it. So, guys, we got to get used to this. It's going to be very crucial. Please write your points as positions at certain times. Nice. You get it? Yes. All right, good. All right, having this information is very, very crucial because so many people the first 2 class periods are messing up. Here is what we do. The derivative is positive until 2. It is negative until 4. That is telling me my position is increasing than decreasing. We have our displacements, we have our accumulations of our derivatives, this positive 7 minus 3. We have an initial position that our position started at 5 at time 0. I add 7, I get 12. I subtract 3, I get 9. There we go. What is my max? Well, here, either through this analysis or just by looking at my 3 points, x of 2 equals 12 is the largest position value. Where's my min? I started at a min. X of 0 is 5 is when I'm furthest left, or the minimum value that I can produce. Okay, try another one for me, and I will give you the missing piece of information that X of 6 is 5. We're going backwards, people. A full sign analysis tells you so much. How far you've traveled, how much you've increased and decreased overall. Distance tells you where we're going to be furthest right, furthest left. X of 6 is 5. We have an end. We got 1, we got 3, we got 5. We got our derivative is negative, 0 positive, 0 negative, 0 positive. We understand the derivative telling me my position is decreasing, increasing, decreasing, increasing. The accumulations of my derivative tell me how much I increase and decrease. This is the new thing we've learned this unit with new context. When I go backwards, instead of adding my accumulations, I'll subtract them. That means I must have came from 3. Subtract negative 4, I must be coming from 7. Subtract positive 6, I got 1. Subtract negative 3, I must be coming from 4. I got every single candidate figured out and written down. The largest one is when I'm furthest right. The smallest one is when I'm furthest left. All right, get your calculators out. Calculators. Calculators up. Yo, let's go back to day 2. Back to day 2. But you're answering a question, when am I furthest right? Okay. Why did I ask you such a long question on your day 2 quiz? That's question 1, 2, 3, where you had to do a full sign analysis and you had to give me 3 different positions. Because what you did on that quiz, you can now answer this question. You pull out your quiz and you look at question 1, 2, 3, that big question. You can look at those 3 values as well as the endpoint, and now you can tell me where you're furthest right or furthest left. When you graph a derivative with your correct window adjustments and your correct zooming, and you find your zeros, and you have your correct window so you know there's a start and the end, guys, you have just written down your 3 candidates for your overall max and your overall min. Now we can see the derivative is negative, you can see the derivative is positive, and we have to find this value. Everybody remind your neighbors, how do you find this value A? Yes, with your y equals 0 graph, which is what I like to do because it's going to be used a lot. Always have y equals 0 graphed in y2. Second CALC intersect, enter, enter, enter. 2.83 2.8264. Make sure you write that down somewhere for your test. For right now, okay. 2.838264. You guys remember how to store that in the home screen? Okay, let's go ahead and store that in the home screen. You guys remember how to find your accumulations of your derivative over your intervals, 0 to a and a to 4. We'll talk about next class how you have to have the correct integrals written down. You have to show where numbers come from. They can't just come out of thin air for your test. Finding the times and the positions where your particle changes direction and at the start and the end gives you the candidates for the overall maxes and mins. Stuff you already did on day 2. You just are going to do it again, and now you're going to be able to answer specific questions. I decrease 9.5 whatever. Just keep that value stored. I math 9 0 to a of y1. Everybody needs to be able to do this. I've accumulated from a to 4, y1. I got 1.355 or just 1.35 ... Just make sure you're going to use that value. You are told x of 0 is 3. Boom. When and where is my particle furthest right? Tell your neighbors. Finish the question. Finish it off. When and where is my particle furthest to the right? What is it? Okay, good. Well, that's when. Where? Come on, finish it off. You got it?
No, I have a question.
Okay.
So I just did the test thing. I don't know what I did.
You have your stat plot. Here's plot 1 on the top. Press enter so that they disappear, and now you can graph.
So it has nothing to do with here, anything here?
That's what it was. Like your stat plot 1 was on. Now you just need to turn it off.
Or you automatically get it right now?
No, you don't do that. I always go into the home screen. I math 9 0 to a y1 to get that number again. Did you store a?
Yeah.
Okay, so 0 to a of y1. All right, now, guys, you should be able to tell by your displacement that you decrease more than you increase. So you should know that your position at the start was when we're furthest right. You started at a positive value. You decreased 9.5. You increased 1.35. You got to be able to figure this out. Negative 6.5, whatever. Add the 1.35. And you get your position at the end, which is definitely not as much. 5.168. Okay? For what? Oh, because I'm recording this. Yeah.